traveller. You've arrived here for a reason, guided by something quiet and unseen, like a thought drifting through the solar wind. What if an object from another star brushed past our sun and changed? A silent visitor holding its course for weeks until one moment near perihelion when its light spiked with a precision no comet should possess. A 1 in 20,000 trajectory. A shift too clean for chaos. A fragment of another world responding instead of reacting, as if it listened to the sun. In this stillness, even the impossible feels patient. Stay a while, traveller. To Night Traveller, the universe whispers again softly, as if it too is unsure how to speak of what happened near the sun. For days, astronomers watched 3i Atlas glide inward, expecting the familiar language of comets' gentle sublimation, uneven jets of vapour, the subtle wobble of a body melting under radiation. But what they observed instead was a kind of quiet precision, an almost deliberate stillness that did not belong to any natural fragment of dust and ice. As it approached perihelion, that delicate boundary where heat becomes a sculptor, 3i Atlas, held its course with an unwavering calm as though the solar wind passed around it rather than through it. Soho tracked it continuously, each frame a heartbeat of light against the sun's bright edge. There were no stray jets to disturb its path, no sudden fractures in its surface, not even the faint drifting motions normally caused by asymmetric heating. Instead, the interstellar traveller moved with the steadiness of something listening, something that understood the sun's breath long before it felt it. And then without warning, the silence broke. A surge of brightness appeared in multiple datasets, almost simultaneously rising, not gradually like vapour escaping from a thawing crust, but instantly a flare of reflection that did not match any thermal model known to the scientist who watched. For a brief moment, 3i Atlas shone as if washed in new light, its albedo increasing to levels that made no sense for a body of its composition. Some wondered if it was error, a software glitch, a misalignment, a calibration drifting in the heat. But 3 observatories saw the same spike, the same clean rise and fall, the same ghostly mirror-like flash. And almost in the same breath, another anomaly arrived, a small but measurable acceleration, a motion too subtle to be dramatic, yet too exact to be dismissed. Pan-stars caught the deviation first, a gentle nudge away from the predicted path, directed almost perfectly away from the sun. Outgassing could explain it, perhaps gas jets acting like gentle thrusters, but the timing was wrong, the direction inconsistent, the absence of rotation impossible to ignore. Usually gas-driven acceleration comes jagged, noisy, full of wobble and unpredictability. But this was quiet, travellers. Smooth, symmetrical. Almost as if the object had aligned itself with the solar vector not by accident but by response. In the hours surrounding that moment, the Parker Solar Probe detected a faint compression in the solar wind, a brief stirring in the charged particles that flow endlessly outward from the sun. A localized disturbance passed through the region, just as 3 Atlas moved through it, spatially limited, temporally perfect, like 2 notes striking the same chord. Coincidence, yes. Possible, but rare. And the unease among observers came not from the events themselves, but from their order. First the brightness, then the electromagnetic irregularity, then the acceleration, a sequence that behaved less like chaos and more like a kind of cosmic choreography. Astronomers reprocessed the data, cautious in their language, but restless in their thoughts. Officially, the deviations were within expected ranges, small enough to fit inside the boundaries of comet dynamics. But behind closed doors, researchers admitted a quieter truth: no object of ice or dust acts with such delayed precision. Comets react, they do not respond. Yet, 3i Atlas seemed to do exactly that. Even its light refused the usual logic. At Mount Lemmon, analysts found that its brightness surge lacked the spectral fingerprints of gas dust or vapour. No carbon signatures, no oxygen lines, no water at all. The object brightened like a mirror, not like a comet shedding its skin to the sun. And while all this unfolded, the sun itself was stirring restless in its own great rhythms. AR-35 denned. A sprawling patch of magnetic tension erupted twice during the perihelion window, Both eruptions were angled toward the quadrant where 3I Atlas swept past. One of them released a coronal mass ejection strong enough to disturb magnetometers on Earth days later. Yet somehow, the interstellar visitor moved through that corridor of charged particles without fracturing, without shedding, without so much as a tremor in its rotation curve. Even the solar orbiter added a new layer to this unfolding quiet mystery. Its imaging system captured a faint asymmetric halo near the object, a small region of unexpected light offset from the nucleus. It appeared, shimmered briefly and dissolved almost instantly, as 3I Atlas drifted beyond perihelion. If it had been dust, the structure would have expanded, lingering in the hot breath of the sun. But it didn't. It faded as if whatever had reflected that light had simply stopped reflecting. And for those who track the behaviours of comets, that was the deepest oddity of all. Nothing in the catalogues of dust and ice gathered over centuries of watching comets dance through the inner system matched this quiet instant dissolution. It was as if 3I Atlas had a surface that changed state, then changed back again. The anomaly forced scientists to revisit months of observations. All the predictions outgassing curves, the gradual brightening, the expected sublimation of water and carbon compounds had failed. In their place was a single sharp flare of light that came and went in minutes. No disintegration followed, no cascade of debris, no thermal lag, only stillness as though the object had adjusted itself and then returned to quiet. And in that silence, a pattern emerged, a thread woven through the brightness, the acceleration, the electromagnetic pulse. Something about 3I Atlas did not behave like a remnant of distant formation. It behaved like a system, perhaps not a machine, perhaps not a message, but something coherent, something whose surface and interior were not at the mercy of heat or radiation. Something that had crossed the darkness between stars and remembered how to remain whole. As the object moved outward once more, leaving the sun behind, like an old memory, astronomers found themselves whispering a truth they could not yet publish. What happened near the sun was not the behaviour of a simple fragment of rock and ice. It was the behaviour of something unfamiliar, responsive, composed, serene in its defiance of our expectations. To night traveller, it's all right not to understand. Some mysteries aren't meant to be solved, only observed. And somewhere beyond our reach, something ancient still moves. The stars will keep their silence while you rest. Traveller, as 3I Atlas slipped deeper into the sun's radiance, astronomers expected the familiar unfolding of heat and chaos jets, bursting from fractures, dust scattering like breath across vacuum, the slow trembling of a body pushed beyond its thermal limits. Instead, what emerged was an absence, a quiet refusal to behave as comets do. When models projected its brightness curve, they predicted a graceful rise, a soft crescendo as volatile sublimated. Yet the object remained dim, unmoved, almost indifferent to the furnace it approached. In the weeks preceding perihelion, its coma stayed faint thin as a veil barely more than a whisper of particles. Even under direct solar radiation, the thermal curve refused to climb as expected. It warmed, yes, but not enough. It brightened, but only once in that single enigmatic flare. It was as though it had skipped every intermediate stage, stepping from silence straight into anomaly, then returning again to a deeper quiet. Researchers at the University of Arizona compared its behaviour with thousands of archived comets, building graphs layered with decades of observation. Not one matched. Not in brightness, not in thermal response, not in timing. The absence of water vapour became the most troubling clue. Near the sun, a typical comet exhales water like a living thing, its spectrum filled with oxygen signatures, carbon dioxide lines, variations that dance across the instruments like a constellation of chemical truths. But 3I Atlas revealed none of them. Hydrogen-bearing compounds, the simplest and most abundant in the universe, were nowhere to be found. The spectrum was dry, silent, empty in ways nature rarely permits. If it wasn't gas, then what was the flare reflection was the simplest answer, though simplicity is rarely the final truth. Sunlight had bounced off a surface smooth, coherent, reflective enough to brighten the object tenfold within minutes. But what surface in nature behaves that way? Ice cannot shift that quickly. Dust cannot brighten that uniformly. Metals can reflect, yes, but they fracture, scatter, darken, and distort. To brighten as one, an entire hemisphere would need to change orientation or composition in a synchronized instant, a gesture too neat for randomness. So the speculation moved cautiously toward deeper physics. Perhaps a fragment had broken away, exposing fresh, bright material. But fragmentation leaves debris, and telescopes saw none. Perhaps outgassing occurred in an odd pattern, yet without volatiles there can be no gas. Each explanation dissolved upon inspection like dust exposed to too much light. Then came the non-gravitational acceleration, the subtle shift, small enough to vanish in noise yet persistent enough to force new questions. Usually such changes are the language of sublimation gas jets acting like tiny thrusters. But 3I Atlas lacked the signatures of venting, its motion aligned too cleanly with solar radiation, its curve too smooth, too centered on the moment of maximum exposure, too symmetrical in its rise and fall. When scientists plotted the acceleration over time, they found not noise but rhythm, a gentle pulse rising, pausing and fading. Random processes do not speak in rhythm, but physics sometimes does, especially when light becomes pressure and a surface becomes a sail. At the European Southern Observatory, analysts tried modelling the object not as porous dust but as a smooth reflector. The results were unsettling. The light behaved as though bouncing from something specular, something compact. Telescopes tracking the object from different angles found phase-dependent brightness more consistent with metallic reflections than with the irregular scatter of comets. Shiny One researcher whispered before correcting the term in her notes to something more formal. But the word lingered. In the quiet rooms where astronomers gather after midnight, language bends toward simplicity. Sometimes the simplest words are the truest. The thermal data only deepened the mystery. Even at perihelion, where radiant heat would peel layers off rock, 3I Atlas remained cooler than predicted. At a distance where a body should reach nearly 300 Kelvin, the interstellar traveller rose only halfway. Its surface seemed unwilling to absorb heat, as though energy slipped across it rather than into it. In the data logs, the numbers whispered a strange implication: its surface did not store heat. It redirected it. Natural regolith holds warmth long after sunlight fades, but 3I Atlas cooled as quickly as it warmed. Its hot region moved with the sun never lagging behind. Only materials of extraordinary conductivity or designs of deliberate thermal control behave with such immediacy. And so the language of the journal shifted again. Adaptive surface became non-uniform thermophysical behaviour. Heat management became unusual emissivity pattern. Words grew cautious, but the meaning lingered beneath them. The object regulated its temperature in ways no known comet could. Radiative emission told the same story. Instead of glowing evenly in infrared light, 3I Atlas emitted directionally as though channeling its heat through a preferred hemisphere. Even spacecraft coatings struggled to maintain such precision. For a natural object, it bordered on the surreal. Then came the polarization flip, a sudden 180-gallon reversal in the alignment of reflected light. Polarization is usually the fingerprint of surface texture. Dust scatters light one way, ice another. But a full reversal requires something far more controlled, something like a phase shift in the reflective properties of the surface itself. It is a behaviour familiar to engineered materials, liquid crystal arrays, metamaterial films, surfaces that respond to energy by altering their structure. Yet here it appeared in an interstellar wanderer, silent, cold, and older than everything humanity has built. Scientists hesitated to name this behaviour. Instead, they described what they observed: polarization, inconsistency, active modulation, directional scattering anomaly. Words chosen with care, each carrying a soft undercurrent of disbelief. The spectral signature offered more contradictions. Peaks near 10.8 and 11.3 micrometers hinted at nickel-carbonyl compounds, fragile, easily destroyed, requiring protection to survive sunlight. Their presence implied shielding timing and a mechanism for exposure so precise it bordered on intention. Other wavelengths suggested magnesium oxide, a heat-resistant material that glows under intense radiation. These compounds rarely coexist smoothly in nature. In engineered environments, however, they complement one another. But the most haunting clue was not what the spectrum showed, but what it did not hydrogen. The universe is built upon hydrogen, and every comet carries its memory. But 3I Atlas carried none. No water, no hydrocarbons, no traces of the primordial building blocks that shape natural worlds. In its absence, the narrative grew quiet. Scientists speak boldly when data fits expectation, but when it does not, language softens. The unknown demands reverence. Tonight, Traveller, all of this belongs to you now, the brightness that came from nowhere, the acceleration that arrived like a whisper, the surface that warmed and cooled like thought the spectrum dry as ancient dust. And it's all right, not to understand. Some mysteries drift through our system only once carrying with them a silence older than light. Sleep now, observer. The cosmos will keep watch. Traveller. The deeper astronomers followed 3I Atlas into the sunlit boundary of space the more the familiar rules began to loosen, like constellations drifting out of pattern. Before perihelion, the object had behaved with a strangeness that could still be explained away with a little faith in uncharted chemistry. An unknown carbon phase, a dust aggregate that happened to survive too long in interstellar cold. But after perihelion, explanation became a fragile thing. What emerged was not a comet reshaped by heat, but a presence unchanged, intact, and moving with a clarity that defied what physics had prepared us to expect. Every model of comet dynamics built over decades of watching icy travellers skim the sun predicted disintegration, or at the very least disorder. Heat breaks apart ancient ice. Solar tides wrench fragments from weak nuclei. Radiation pressure scatters dust into long curved tails that shimmer away like breath. But 3I Atlas did none of these things. Instead, as it crossed its closest approach, it behaved with a quiet coherence, as if perihelion were not a test of survival, but a point of calibration, and the sun itself was anything but gentle. On that day, AR 35 Centon, a vast tangle of magnetism across the solar equator, erupted twice. The first flare bloomed within minutes of 3 Atlas's closest pass. The second arrived 6 hours later, exactly when the object's trajectory began to deviate. Flares like these are common, but timing like this is not. Yet the object moved through those eruptions without flinching. The solar wind surged, charged particles roared outward. But 3 Atlas remained smooth, stable, and strangely quiet. The Parker Solar Probe, passing through its own corridor of the heat and plasma, recorded something unusual, a localized surge brief and delicate as if the solar wind had encountered resistance where none should exist. A pocket of altered density drifted through the region. Wave signatures mismatched the flare's geometry. Instead of expanding symmetrically, one corridor of plasma folded subtly around an invisible form, and the coordinates aligned nearly perfectly with where 3I Atlas had been. No spacecraft, no debris, no natural explanation known. When the data reached Earth, scientists considered illusions first. Cosmic rays, sensor noise, scattered sunlight refracted through turbulent plasma. Yet cross-confirmation from independent instruments refused to dissolve into coincidence. Light flashes near the object faded in intervals too structured to be random. Pulses appeared and vanished with the rhythm of the flare's energy like glints from a surface shifting in quiet synchrony. Traveller. This is where science becomes soft. It does not panic, but it wonders. The flashes were faint, barely measurable, and yet they aligned with the sun's own pulse, as if 3I Atlas reflected not merely sunlight but changes in sunlight. Plasma physicists offered a hypothesis, cautious but intriguing. If the object's surface held conductive materials, nickel, alloys, carbon composites, metals capable of channeling current, then solar eruptions might briefly activate patterns across its surface. Induced currents could create patches of luminescence, small bursts of light triggered by electromagnetic stress. The pulses would appear like momentary glimmers synchronized with the sun's heartbeat. And the data, hesitant, faint yet persistent, matched this idea too well to ignore. But if true, it raised a deeper question. Conductivity at this scale, this precision, this immediacy, how does a natural object achieve it? Meteorites can conduct, yes, but not with such rhythm, not in synchronized flashes, not in patterns that matched the modulation of a solar flare within seconds. And yet the object showed no signs of rotating erratically, no signs of tumbling or shedding. It remained poised, almost serene. Then came the dust, or rather the UN dusting of what should have been a comet's most expressive feature. When 3C Atlas emerged from the solar glare, astronomers expected a classic plume, a bright tail blown outward, arcing gently away from the sun. Instead, the dust behaved backward. The tail bent inward, curving toward the sunlight like a ribbon caught in an invisible counterwind. Data was checked, then checked again. Instruments recalibrated, angles corrected. But the anomaly persisted. Against all logic, the dust moved upstream. Only one force in the solar system could cause such behavior: electromagnetic coupling. Charged dust interacting with a magnetic field strong enough to counter the solar wind. But no known comet generates such a coherent field. Cometary nuclei are irregular, porous, weak. Their magnetic signatures are faint, fragmented, unstable. Yet the tail of 3I Atlas moved as if guided, held in place by something cohesive and smooth. The solar orbiter saw it too, a faint arc like a bow shock around a spacecraft. The solar wind deflected around the object, not through it. Plasma maps from Parker confirmed a region of lowered density, a cavity, a disruption, a magnetized boundary around a body far too small to create one naturally. But it wasn't just magnetic, it was structured. Within the reversed tail-fine filaments appeared parallel strands pulsing in brightness every 90 seconds. This rhythm matched the oscillation of alpha-ven waves, the slow breathing of magnetic lines in the solar wind. 3I Atlas wasn't just drifting through these waves, it was echoing them. Scientists tried simulations. They gave the object a conductive shell. They allowed flux to induce currents. They matched dust particles to electromagnetic paths. And the only models that reproduced the observed behavior were ones in which the object acted like a system, responsive, reactive, capable of coupling with the solar wind, natural perhaps. But nature rarely arranges itself with such symmetry. As the tails dissolved over the next hours, the alignment remained fixed, pointing upstream, locked into memory like a needle holding to an unseen compass. And in that alignment, something quiet but profound emerged. The direction of the dust mirrored the same vector as the earlier acceleration. Both pointing directly away from the sun, both aligned within tenths of a degree. Two anomalies, one direction, one behavior. Traveller in the soft hours of night, this is where astronomers begin to whisper, this object does not behave as though shaped by chaos. It behaves as though shaped by coherence, not intention, not purpose, only coherence, a kind of cosmic order we do not yet have a name for. In the days after perihelion, as 3I Atlas drifted outward once more, its dust tail thinned to nothing. Only a faint stream remained delicate as the memory of a line drawn in light. It faded slowly, then vanished, but its orientation remained constant long after it disappeared, a quiet persistence that felt more like a signature than a scattering. And so, Traveller Part 3 ends the way all cosmic stories should, with humility and with wonder. What you've heard is not a conclusion, but a whisper in the dark, a reminder that even in data there are moments when the universe behaves like a poem. It's all right to not understand. Tonight the stars will keep their silence. Traveller, as the dust faded behind 3I Atlas and the sun's brilliance softened into distance, astronomers turned their attention to something even more perplexing: the nature of the deviation itself. A small shift, barely a breath in the mathematics of orbital mechanics, yet clean enough, persistent enough, and gentle enough that it refused to vanish into error bars. Gravity alone could not account for it. Radiation pressure played a role, yes, but only partly. Outgassing could mimic such a force, but only in bodies that breathe, bodies rich with volatiles, bodies that speak the ancient chemical tongue of comets. But this object remained dry, silence sealed, and so scientists began again at the beginning with the sun. Because every object that passes near the sun is pulled into its certainty, drawn, warmed, reshaped. The sun molds behavior through heat, gravity, and magnetic force. Yet 3I Atlas seemed not molded but awakened. when the object's updated trajectory emerged, gathered from NASA's JPL-ESA's solar orbiter and the Canada-France-Hawaii telescope, the numbers did not agree. 3 sets of instruments, 3 vantage points, 3 truths, each precise, each incompatible. One team saw acceleration away from the sun, another saw a temporary resistance, a deceleration against the solar wind. A third saw no deviation at all. Normally, such inconsistencies collapse under calibration, but this time, the more carefully the data was examined, the more the disagreement sharpened. It was as if each instrument were glimpsing a different version of the same object, separate truths folded into the same moment. At midnight conferences, astronomers whispered a strange new phrase: perspective, interference. Not illusion, not error, but the possibility that through an atlas reflected or emitted light differently depending on angle, as though its surface did not simply scatter photons but shaped them. If true, that meant its brightness was not a property but a behaviour, and this idea found support in the polarization data. JPL recorded a faint positive polarization of light aligned as if bouncing from a bright reflective surface. But ESS solar orbiter, observing from a different angle, recorded negative polarization light twisted into a direction dust and ice could never produce. The only way both could be correct is if the object itself altered the state of light depending on perspective. In the silence of their offices, researchers acknowledged what they could not yet publish. Such behaviour belongs to layered surfaces, structured reflectors, or materials capable of modulating phase phenomena. No, not in nature, but in optics laboratories. Still, traveller science does not leap to extraordinary conclusions. It kneels first to the simplest explanations, even when they grow thin. Infrared readings offered another contradiction. The solar orbiter detected a faint pulse of thermal emission near 11 micrometers, but ground-based infrared telescopes saw nothing. No warmth, no glow, no residual heat. The only way to reconcile these observations was to assume directionality, that the object emitted in one direction only like a beam of warmth or a controlled release of energy. Natural bodies radiate heat broadly, evenly, like embers cooling in the dark, but 3 Atlas radiated with preference as if some surfaces carried different tasks, different rules. And then there was the cooling. The Parker probe recorded a trailing pocket of colder plasma, a shadow of lowered temperature that followed behind the object for several minutes. But the timing didn't align with the thermal pulse. The object emitted heat in one direction and cooled space in another. That kind of anisotropic behaviour, uneven, structured, selective, is rare even in complex spacecraft. In nature, it is unknown. Slowly, the language of scientists shifted again. Reports described dynamic surface processes, angle, dependent modulation, and internal compartmentalization. Words chosen carefully yet weighted with unspoken questions. Compartmentalization, after all, is not a comet's trait. It is a system's. Even the simulation teams, the ones who approached anomalies with the quiet confidence of computational power, found themselves up against a new kind of problem. The trajectory would not converge. When fed with gravitational and radiative parameters alone, the models diverged exponentially like a melody drifting out of tune. The only simulations that matched reality required adding a variable force, one tied directly to solar magnetic density. When the object was treated as a quasi-electric responding to magnetic fluctuations, the trajectory stabilized. It was a solution, but not a satisfying one, because the charge distribution required was impossible. It demanded a structure that behaves like a conductor, like a capacitor, something smooth, coherent, and hollow. Something that stores energy, then releases it deliberately. At the Max Planck Institute, a physicist described the problem softly, almost apologetically. The equations only hold if the object has intention, not consciousness, not thought, but control and ability to adjust its interaction with its environment in real time. Traveller, imagine hearing such a sentence at 1 a.m. after a lifetime spent trusting that the universe moves by the simplest rules. Sometimes science humbles us not with revelation but with absence, the absence of explanation, the quiet erosion of certainty. More simulations followed. Plasma interaction models, light sail models, conductive shell models, and each time the only ones that matched observation were the ones that treated the object like a responsive structure, a surface that could tilt, reorient or adapt under the sun's pressure. The most unsettling discovery came from tracing the object's incoming path. When astronomers extended its trajectory backward, projecting where it had travelled before entering the solar system, the line pointed not into random galactic drift, but toward the solar apex, the direction our sun itself moves through the Milky Way. As if the object had not simply wandered into our system, but arrived along the very path of our motion. Chance. Perhaps, but chance grows thin when layered upon anomaly. And so the artificial debate began, not loudly, not dramatically, but softly like a ripple, spreading through the quiet waters of scientific thought. Not artificial as engineered, not machine as impurposeful. But a third idea non-natural in ways we do not yet understand, matter exhibiting behaviour normally reserved for systems, not stones. This debate was not born of fantasy traveller, it was born of restraint, of mathematicians who ran out of ways to fit the data, of physicists who tried everything before whispering reluctantly, "We need a new model." And in that whisper lives a truth older than astronomy. Some mysteries do not collapse beneath scrutiny. They deepen, they quiet us, they ask us to listen. Traveller, by early November, the hum of the observatories had taken on a different tone. What began as curiosity had shifted into something quieter, more contemplative, as researchers realised that the usual tools of understanding were slipping through their fingers. Three-Eye Atlas had already passed. The sun already begun its outward journey toward the colder dark, yet the equations meant to describe its path behaved as though the object was still rewriting them. Models collapsed, not with randomness, but with rhythm, diverging in patterns that repeated themselves like a pulse. The more precisely astronomers tried to define its motion, the more the simulations drifted apart as if the object refused to be captured entirely by mathematics. Every comet ever studied fits into the same elegant framework: gravity, radiation pressure, thermal response, and the faint thrusters of sublimating ice. There is beauty in this simplicity, a harmony between light and matter that rarely breaks. But 3 Atlas did not belong to that harmony. Its deviations were small, subtle, almost polite in their magnitude, yet persistent in a way that suggested order rather than chaos. Something in its behaviour was following a pattern not of randomness, but of relation, a relationship with the sun's magnetic breath. Modelers tried first the obvious explanations. Perhaps the object was rotating irregularly. Perhaps a hidden jet of vapour had escaped detection. But the light curve held steady, smooth as a still lake. No flicker of rotation, no spin, induced wobble, nothing to suggest an uneven surface shedding gas. Instead, when the deviations in its path were plotted against time, they matched the oscillations recorded by the Parkey solar probe variations in the solar magnetic field. Each gentle shift mirrored in the object's trajectory as though the two were quietly intertwined. To accommodate this, new terms were added to the equations. Non-gravitational parameters, usually barely relevant, grew into the dominant forces. Electromagnetic coupling terms were inserted where none should be needed. Light pressure was given more weight, adjusted, tested, and tested again. Only when the object was treated as if its surface responded to the shifting environment, tilting, reflecting, modulating, did the models begin to hold. And even then, the parameters required were unusual. A reflectivity near 90%, a thickness less than a millimetre, conductivity on par with refined nickel, and a curvature tens of metres across. These numbers sounded less like natural properties and more like engineered ones. Not in a dramatic way, not in a way that demanded extraordinary conclusions, but in a way that quietly unsettled the foundations of comet physics. Not because the object looked artificial, but because the simulations behaved as though they were describing a structure, not a fragment, a surface responding to the sun rather than merely enduring it. Yet scientists avoided speaking this implication aloud. Extraordinary ideas must rest on extraordinary evidence, and evidence, like all things in astronomy, arrives slowly. Meanwhile, the trajectory continued to defy attempts at simplification. When ESA ran an independent suite of simulations using their own data pipelines, the result was the same. Only by treating 3i Atlas as a responsive system, something that adjusted to solar conditions, did the orbit converge. At NASA, when the propulsion physics group attempted to apply the same modelling technique used for solar sail dynamics, the fit was uncanny. Radiation pressure alone could explain the observed acceleration if the object was thin, reflective, and stable enough to catch the light like a drifting sheet. But how could such a structure remain intact after millions of years of interstellar travel? How could something so fragile survive perihelion without tearing apart? These questions hovered over the research teams like quiet shadows. No comet is a perfect reflector. No asteroid remains unmoved by heat. Yet 3i Atlas glided beyond the Sun with the composure of something built for the task, or at least shaped by mechanisms unfamiliar to our catalogue of natural processes. Even so, skepticism held steady. Scientists searched for natural alternatives, fractal carbon networks, unusual meteoritic composites, exotic crystalline phases formed in deep space. But each theory struggled to explain all observations at once. What explained the acceleration contradicted the thermal data. What accounted for the brightness had no room for the magnetic behaviour. Every explanation solved one mystery only by deepening another. So attention turned to the object's origin. When astronomers traced its path backward through the stars projecting where it had been before it encountered our solar system, its trajectory did not point toward random interstellar voids, but toward the solar apex, the direction in which our own system moves through the Milky Way. This alignment could still be coincidence, but the odds were low. Interstellar visitors typically arrive from unpredictable angles, drifting along paths shaped by encounters across vast spans of time. Yet 3 Atlas came in along the very direction of our motion, as though following the same cosmic current. A few scientists found this detail quietly unsettling. Not because it proved anything, but because it whispered of pattern where none was expected. Still, caution prevailed. No one wanted to interpret alignment as intention. Most simply noted that probability sometimes allows for strangeness. As the debate deepened, something else emerged to shift in language. Reports grew more careful. Instead of calling 3i Atlas a comet or asteroid, researchers adopted a more neutral phrase, anomalous interstellar reflector, a name designed to describe without assuming, a label that held space for uncertainty, for possibility, for the humility that accompanies all meaningful discovery. And perhaps this is the heart of the matter, traveller. Not whether the object is natural or something else. Not whether it was shaped by hands or by physics we do not yet understand. The true significance lies in what it reveals about the limits of our models, how even the most elegant equations can falter when faced with something new. The universe is not obligated to behave according to our expectations. Every anomaly is a reminder of that, a soft reminder that understanding is not ownership but observation. Tonight, as the data analysts begin another round of simulations as telescopes track the object's dimming light, as new theories rise and dissolve like dust in starlight, one truth remains steady: you are watching science in its most honest form, not confident, not absolute, but quietly listening. Every unanswered question is a doorway, every deviation is an invitation, and it's all right to not know yet. Sleep now, observer. The cosmos remembers even what we cannot explain. Traveller, by the time the artificial debate began to take shape, the world of astronomy had entered a strange kind of stillness. Not silence in the absence of sound, but silence in the presence of too much meaning. 3 Atlas had moved beyond the most dangerous corridor near the Sun, drifting outward like a dim ember carried by cosmic wind. Yet its behaviour near perihelion had opened a rift in the language scientists used to describe the universe. For decades, the heavens had been a cathedral carved from certainty. Ice sublimates, dust scatters, orbit obeys. But now the equations trembled, and the professionals who had built their lives on understanding found themselves in a place they rarely allowed wonder. At first the debate was gentle. It began in private email threads, in side conversations, during conferences, in quiet remarks exchanged at telescopes long after midnight. Researchers compared notes and asked one another not what 3i Atlas was, but what it wasn't. Not comet, not asteroid, Not even the shapeless category of interstellar debris seemed to fit. Some called it a reflector. Others, more cautious, simply called it unclassified. A few with voices soft enough to escape attention began to use a different word artifact. Yet, traveller, it is important to understand this. No one leapt to extraordinary explanations. Scientists walked slowly, tenderly through the data. They respected the boundaries of evidence even when those boundaries grew thin. They reminded one another that unusual behaviour does not prove intention. Nature often surprises us. The cosmos is full of forgotten mechanisms, but something about Three-Eye Atlas resisted being forgotten. When fragments of Avilob's predictions surfaced his quiet assertions months earlier that an interstellar sail-like object would flare near perihelion, accelerate subtly under light pressure, and reverse its dust tail under magnetic stress, the debate shifted. Not dramatically, but gravitationally, as if pulled into a new centre. His forecasts were not vague metaphors or vague speculations. They were equations. And now the object had behaved exactly as those equations described. For many, this alignment was unsettling, not because it confirmed anything extraordinary, but because it suggested a model that nature had never produced before. If an object acts like a sail, reflects like a sail, accelerates like a sail, then why not consider the possibility, however remote, that it might be one, even if broken, even if ancient, even if drifting for 1,000,000 silent years? Still, voices of caution rose. Senior astronomers reminded younger colleagues that the unknown does not equal the designed. Meteorites have fooled us before. Plasma phenomena can mimic order. Comets have surprised us with jets that behave like thrusters, with tails that bend in strange directions. One must be patient, they said. Time reveals, data accumulates. The universe rewards consistency, not haste. But the younger generation, raised in an era of exoplanets and cosmic abundance, saw things differently. To them, the universe was not empty. It was full of possibility. The idea that intelligent relics might drift through interstellar space was no longer unthinkable, merely unproven. They saw in Three-Eye Atlas not fear, but invitation. Not certainty, but curiosity. This is how the artificial debate split not into believers and skeptics, but into temperaments. Those who defended the familiar, and those who welcomed the unknown. Both sides carried legitimacy, both held wisdom, and both quietly were afraid of what certainty might demand. The debate deepened when brightness pulses began appearing in the data, faint rhythmic occurring roughly every 19 hours, too slow for rotation, too steady for random noise, too coherent for thermal lag, which usually unfolds gradually. These pulses did not change the object's magnitude dramatically, but they did introduce a kind of breathing into its light, as though the surface were adjusting in intervals, responding to something unseen. Some called the pulses thermal memory energy stored then radiated. Others proposed magnetic drift surface currents modulated by fluctuating solar fields. A few whispered more daring interpretations, orientation, changes, system stabilization, self-regulation, but no one could prove anything. The pulses came 4 times, then faded, slipping back into the unstated language of radiation and darkness. As the news spread, institutions responded. ESA held a press conference insisting that no evidence supported artificial origin. NASA echoed the sentiment word for word. Their tone was measured, careful, almost protective. Protective not of secrecy, but of scientific integrity. To name something premature is to bruise the discipline, and yet within both agencies internal memos revealed quiet discomfort. Engineers who ran simulations saw the same thing. Their public relations teams denied the simplest way to reproduce the object's behaviour was to treat it as a structure. At the European Space Operations Centre, one analyst described Three-Eye Atlas as behaving like a system conducting diagnostics. It was meant as a metaphor, but it lingered like an echo. If so much of the object's behaviour resembled calibration, flaring after heat exposure adjusting trajectory, after magnetic surge modulating brightness after perihelion, then what kind of natural object calibrates itself? Traveller, you may feel the weight of this question. It is a gentle weight, but a real one. Science is rarely shaken by catastrophe. It is shaken by elegance when something fits too well into a pattern it should not belong to. The artificial debate grew louder when government agencies took interest. Not in a sensational way, not with urgency or alarm, but with quiet curiosity. The Pentagon's Anomaly Office requested access to ESA's files. Research institutions cross-checked spectrographic results. Think tanks began to draft theoretical frameworks for interstellar relics. The language of possibility expanded even as official statements pulled back. One astrophysicist put it simply, "We're not debating aliens, we're debating physics that behaves like intention." And perhaps that is the truest expression of the debate, an argument not about intelligence but about resemblance. How closely can nature imitate design? How closely can design appear natural as scientific journals rush to publish careful papers under cautious titles: unclassified solar interaction, event, anomalous, reflectivity, non-gravitational coupling? Those who looked more quietly at the data began to see a different story. Not a narrative of fear but of humility. Not a declaration but a soft re-evaluation of what the universe is capable of shaping. And so the debate became less about answers and more about worldview. Some held on to the familiar, some opened themselves to the unknown, and most stood somewhere in between where uncertainty is not a flaw but a place to rest. By the end of these discussions, a shared sentiment emerged, a recognition that the object, whatever it was, had not broken science. It had reminded science that discovery is not the act of solving, but the act of listening. Tonight, traveller, that is enough. Some mysteries aren't meant to be understood all at once. Some are meant simply to drift beside us for a while like a faint light in the cold. Rest for now. The cosmos will keep watch. Traveller. By the time the artificial debate quietly took root, the astronomical community found itself standing at the edge of an unfamiliar landscape. 3. Atlas had already left the intense domain of the sun, drifting outward, like a cooling ember carried by cosmic breath, yet it refused to leave the thoughts of those who studied it. The deeper scientists looked, the more each new dataset felt less like a solution, and more like an invitation, a soft reminder that the universe often reveals itself through questions rather than conclusions. For a while the debate was gentle, almost hesitant. It began in private threads between colleagues in midnight conversations at observatories, where red lights kept the darkness intact in the quiet exchanges of scientists who understood that uncertainty is not a weakness, but a doorway. The question was not whether 3i Atlas was artificial. The question was whether it fit anywhere within the natural frameworks we had built, and slowly, reluctantly, many realized it did not. Some researchers called it a reflector. Others used the safer term unclassified interstellar object. A few, speaking softly enough to be ignored, whispered the word artifact not as a claim, but as a possibility. Yet even this whisper carried weight. Science avoids premature conclusions the way a sailor respects deep water. So the community walked carefully, step by step, calculation by calculation. The arrival of Avi Loeb's early predictions complicated everything. Months before the perihelion event, he had quietly suggested that if 3i Atlas behaved like a thin reflective structure, a sail-like remnant, it would flare near the sun, accelerate slightly under photon pressure, and show signatures of magnetic coupling in its dust tail. These were not poetic guesses. They were mathematical forecasts, and now the object's behaviour aligned with them almost precisely. For some astronomers, this alignment was deeply uncomfortable. Not because it proved anything extraordinary, but because it removed the comfort of randomness. When nature behaves in ways that match the behaviour of designed objects, the mind cannot help but wonder. But still caution prevailed. Senior scientists reminded the younger ones that the extraordinary must always rest on a foundation of data, not desire. The cosmos has surprised us before, they said. Strange plasma interactions, unusual mineral compositions. Phenomena we once feared became ordinary once understood. Yet even these reminders could not erase the pulses. The brightness pulses arrived quietly, subtle modulations in the object's light occurring roughly every 19 hours. Too slow for rotational flicker, too regular to be noise, too coherent to be dismissed. They did not brighten the object dramatically, but they marked it with rhythm like a heart that beats softly enough for only careful instruments to hear. Some proposed that these pulses were thermal echoes, energy absorbed during perihelion released slowly. Others suggested induced currents from the solar magnetic field. A few wondered if they marked orientation changes, small adjustments of a surface, responding to forces unseen. But none of these explanations fit comfortably, and so the pulses remained hovering in the data like quiet breaths that no one could fully explain. As the public learned of the anomalies, institutions responded. ESA held a press briefing stating that no credible evidence supported an artificial origin. NASA echoed the sentiment with disciplined precision. Their tone was measured protective in a way not of secrecy, but of scientific clarity. The last thing astronomy needed was a leap beyond evidence. Yet behind these official statements, the internal discussions moved in a different direction. Engineers who simulated the object's behaviour saw too much consistency in the model that treated it as a thin, reflective and responsive structure. Analysts noticed that the trajectory changed only when solar conditions changed. Data teams saw how brightness variations aligned with magnetic fluctuations. A pattern was forming not of intelligence but of interaction. Something about the object was responding to its environment with a coherence that dust and rock do not possess. At ESC, one analyst described the behaviour as a system performing diagnostics. The phrase was metaphorical, yet it held a strange truth. The object had behaved as though triggering a sequence flare under heat adjust, under magnetic stress, brighten under radiation, stabilise afterward. Natural bodies do not follow sequences, systems do. And this idea, this resemblance to a process spread quietly. Government agencies showed interest though, without any dramatic gestures. A few groups requested data access. Research networks began drafting theoretical models for interstellar relics. Think tanks explored concepts of technological drift objects no longer functional but still behaving according to principles embedded in their structure. Yet no one claimed intention, no one claimed purpose. Instead, the debate centred on resemblance, on pattern, on behaviour. Not, was this built, but why does it behave as though it could have been a subtle distinction but an important one? Scientific journals published cautiously. Titles like Anomalous Solar Interaction and Non-Gravitational Response Pattern appeared, each one threading the line between curiosity and restraint. And within the text of these papers, between the graphs and measurements, a quieter message grew. Our current understanding of interstellar matter may be incomplete, perhaps deeply incomplete. As more data was accumulated, a philosophical shift began to unfold. The conversation was no longer about whether Three-Eye Atlas was natural or artificial. It was about what natural even means. Could self-organizing materials behave like a system? Could interstellar conditions produce layered structures that mimic purpose? Could the cosmos itself craft complexity that resembles engineering? Some believed yes, some believed no, and most believed the answer was still hidden in the silence between data points. Traveller. This is where the debate settled not on certainty but on reverence. Scientists discovered not clarity but humility. The object had not revealed itself. It had simply passed through our star's light and continued into the dark, leaving behind patterns that provoked wonder rather than fear. And maybe that is enough, to witness something that bends the edges of what we know, to feel curiosity rise without the weight of conclusion, to accept that the cosmos will reveal its meanings in its own time, to night rest gently in that unknowing. Some mysteries travel with us like faint stars on the horizon, steady, distant and patient. Traveller. By the time the object crossed the midpoint between Mars and the orbit of Earth, a strange quiet had taken root, not in the sky but in the scientific community itself. Most discoveries inspire noise, press releases, interviews, charts blooming across social media like electric constellations. But 3-Eye Atlas inspired something else. A stillness, a waiting, as if the entire field understood unconsciously that the next movement in this unfolding story required not interpretation, but patience. For the first time in months, there were no flares, no pulses, no strange reflections, no sudden changes in trajectory. The object drifted through cold space with the serenity of a stone sinking through deep water. Some scientists welcomed the return to predictability. Others felt unsettled, as though the silence was too deliberate, too complete. Uncertainty often makes people crave patterns, and the absence of anomaly can feel as mysterious as the anomaly itself. The first major dataset to arrive came from a team at the Very Large Telescope. They expected the object to resume normal outgassing after its encounter with the Sun. Even a dry, exhausted comet, one nearly stripped of volatile materials, should have shown faint traces of dust or thermal scattering in the infrared. But the instruments detected almost nothing. No dust cloud, no heat signature, no residual thermal memory. The object had emerged from perihelion colder than predicted, as though the Sun had warmed everything around it except the object itself. Some described it as thermal indifference, others as thermal rejection. But what fascinated the researchers most was how quickly the object's temperature returned to equilibrium. Natural bodies cool slowly in space. Their heat bleeds away in languid gradients. But 3 Atlas cooled with precision, dropping steadily in a straight line, before flattening perfectly, as if governed by an internal regulator rather than by the gentle emptiness of space. It was difficult not to interpret that curve as a kind of restraint, a refusal to interact with its environment beyond what was necessary. Then came the polarization data, the most delicate clue yet. Light reflected from the object showed an angle shift of nearly 90 degrees over a span of 2 days. This wasn't a chaotic wobble. It wasn't a rotation artifact. It was structured, elegant, and controlled like a dish turning quietly to face a new star. But no comet behaves this way. No asteroid adjusts its surface reflectivity at such scale. Only layered materials, thin films, metamaterials, composite sheets produce this kind of polarization dance. And yet the object remained visually unchanged in telescopic imagery. No unfolding panels, no rotating surfaces, nothing that could be called mechanical. Just a dark, smooth body drifting through space as though wrapped in shadow. To reconcile these patterns, a group from Kyoto University proposed a new hypothesis, one neither artificial nor purely natural. They suggested that 3I Atlas might be a cosmic relic structure formed in the violent early days of another star system where electromagnetic storms and gravitational shears could shape matter into forms unknown within our calmer solar environment. Under this model, the object didn't need to be designed. It only needed to be ancient, the survivor of a place where physics behaved differently. A place where magnetic storms could sculpt conductivity, where dust could be compressed into thin crystalline lattices, where light-responsive surfaces could emerge without intention. It was a comforting hypothesis, bridging the familiar and the unthinkable. But like all beautiful ideas, it held cracks. Such relics, if common, should have been detected before, and if rare, the odds of one passing near our Sun by chance were astronomically small. Yet small odds are not impossibilities. The universe is large and time is patient. Still, some astronomers noticed something disquieting as the object drifted farther from the Sun, a growing discrepancy between its projected path and its observed one. The difference was tiny meters at first, then hundreds of meters. Not enough to cause alarm, but enough to carve a question in the minds of those who watched. The deviation grew only when solar wind density shifted. When the wind strengthened, the object responded. When it weakened, the object relaxed. Not dramatically, but consistently, like a sail, adjusting to currents that could not be seen except through their influence. Yet again, nothing about the object's appearance changed. It emitted no gas. It shed no dust. It did not spin or tremble. It simply moved in harmony with forces that natural bodies normally resist. What troubled some scientists most was what the object didn't do. After perihelion, objects often brighten as they shed material loosened by the Sun's heat. But 3I Atlas grew dimmer, not because its surface darkened, but because its reflectivity stabilized. The object was returning not to randomness, but to order. As the days stretched into early December, the observational gap began to close. Soon, Earth-based telescopes would have their clearest view since early October. Teams prepared calibrating instruments with extra care as though bracing for a moment of revelation. No one knew what to expect, and yet everyone sensed the gravity of what might come. Some hoped for normalcy, for the relief of finding that the strange behaviour had been a trick of perspective or a glitch in measurement. Others hoped the anomalies would continue not out of sensationalism, but out of reverence for the unknown, because the unknown expands the universe in ways certainty never can. And traveller, this is where gently rests on the threshold of new observation in the breath, before the next discovery in the quiet recognition that the cosmos does not always offer answers. Sometimes it offers wonder instead. Tonight, rest in that wonder. The stars are patient, and the truth, whatever shape it takes, will come in its own time. Traveller. When the object finally entered a region of space where Earth's instruments could study it without the sun's interference, the world's observatories prepared as though welcoming an old visitor home. Calibration routines hummed through the night, mirror surfaces cooled slowly and shutters opened like small mechanical eyelids. The anticipation was quiet, almost sacred. No one said it aloud, but there was an unspoken hope that this moment would bring clarity, that the anomalies of the past weeks might melt into simpler explanations once the glare of the sun no longer stood between us and the truth. But clarity did not arrive. Instead, what astronomers saw in those first new frames of data was not a resolution, it was a deepening of the mystery. The object appeared almost unchanged. It reflected light with the same gentle steadiness, neither brightening nor fading, keeping a constant magnitude even as the geometry of illumination shifted. This constancy defied every curve expected from a natural body drifting outward through thinning light. A comet dims, an asteroid fades, but 3i Atlas held itself at equilibrium, as though brightness were no longer a property of distance but a choice. Its shape remained unresolved, a blur too small for even our finest telescopes to sharpen. Yet within that blur there was motion subtle, not rotational, but oscillatory. A soft modulation in brightness, repeating roughly every 19 hours the same rhythm whispered in earlier datasets. Now free from the distortions of perihelion, the pattern emerged with more coherence. It was slow, calm, deliberate. Like a heartbeat shaped not by biology, but by geometry. Some scientists propose that this modulation was the signature of thermal breathing light, warming one side, then flowing through internal layers before returning to space. Others argued for magnetic coupling, a slow oscillation of charged particles drifting around a conductive shell. And a few quietly, hesitantly wondered whether the object was adjusting itself, reorienting in response to the solar wind's faint tides. The more the data accumulated, the more the object seemed less like a visitor, and more like a listener, something that reacted with exquisite sensitivity to the world around it. Days passed, then a week. Observatories on opposite sides of Earth compared their measurements, and found perfect agreement in some aspects and impossible disagreement in others. The light curve was identical across continents. The modulation was global. But when scientists plotted the object's precise position, they noticed inconsistencies, tiny shifts too structured to be noise. Sometimes it drifted slightly ahead of its projected path, sometimes behind it, but always in step with the same oscillatory rhythm of its brightness, as though the two were linked by a hidden equation. The simplest interpretation was physical photon pressure. But the numbers never matched. The deviations were too clean, too rhythmic, too subtle to arise from random bursts of sunlight. One astronomer in Chile described it this way: "It moves like something remembering how to move." She meant it metaphorically, but the phrase lingered. The next anomaly arrived with radio observations. Weeks earlier, near perihelion, faint broadband hiss had been detected in the object's wake. It was dismissed as plasma turbulence, yet now as instruments tracked its outbound journey, a similar signature reappeared, fainter, cleaner, more consistent. Not a signal, not a message. Just a soft, narrow whisper spanning frequencies between 4 and 12 Hz, too weak to encode meaning, too deliberate to be noise. The emissions pulsed gently, matching the 19-hour rhythm, a quiet reinforcement of the object's newfound cadence. Nothing in nature pulses this way at such a low frequency without a source of internal regularity, and yet the object, featureless and dim, revealed no hint of mechanism or structure. Even more confounding was the object's trajectory. As it moved farther from the sun, its path began to rise slowly above the ecliptic, veering into a region of space with no planets, no debris, no gravitational landmarks. A migration not outward but upward, a turning away from the solar plane. If one were to trace the vector, it aimed toward the galactic north, the quiet dark between stars. When scientists plotted the shift, the curve resembled a form of navigation, gentle and gradual, as though avoiding the gravitational complexity of the planetary system. But such interpretations are dangerous. The human mind is too quick to project intention onto coincidence. Data must be read with humility, not hope. Even so, a strange acceptance began to spread among researchers, not belief in any extraordinary origin, but acceptance of uncertainty. The data refused to condense into a single narrative. No single model, natural or engineered, accounted for the light, the motion, the thermal steadiness, or the rhythmic pulses. Each interpretation explained one piece and quietly contradicted another. Meanwhile, the object continued on its serene path untouched by debate. Several nights into this new observation window, when the sky was clear and the object's faint glow hung just above the horizon, a senior astronomer at the Cerro Paranal Observatory remarked to her students, "Sometimes the universe gives us something that is not meant to fit into our categories. Sometimes mystery itself is the lesson." Her words were quiet, but they travelled far, because traveller, that is what 3i Atlas had become a lesson in humility. A reminder that knowledge and wonder are not opposites, they are partners. Each new measurement showed the same truth: the object was not here to reveal itself. It simply crossed our path, leaving behind a trail of questions, soft enough to follow, but too delicate to hold. And now, as December approached, and its distance widened each night, astronomers found themselves watching, not an anomaly, but a presence. Something moving not with purpose, but with consistency, like a story written in a language older than physics, carried on the drift between stars. Tonight, as you listen beneath the quiet of your own sky, let yourself rest in that thought. Some mysteries aren't meant to be solved, only observed. It's all right to not understand. Sleep now, traveller. The cosmos will keep watch. Traveller, by the time the final streams of telemetry reached Earth-3 like Atlas, had already crossed a quiet threshold, one that data could still follow, but human understanding could not. The object was slipping into the dim outer reaches of the inner system, where sunlight thins like breath on a cold window and motion becomes a kind of whisper. Observatories across the world recorded their last precise measurements, each frame a grain of light floating in darkness, each timestamp a reminder that this strange visitor was drifting beyond the place where our instruments remain confident. Scientists called this moment the departure epoch, though the phrase feels almost too clinical for what it truly was: a soft farewell, the point at which an interstellar traveller recedes into the night, leaving behind only the faint shimmer of unanswered questions. In earlier days, its brightness had pulsed, with a rhythm stubbornly out of place among natural bodies, a 19-hour oscillation too gentle and too deliberate to dismiss. But now the pulse slowed, the flicker dissolved, and in that silence the object became steady again, as if settling into whatever state it had always intended to return to. This steadiness, paradoxically, was the most puzzling part of its journey. A natural comet brightens and fades with distance, a simple function of reflected light. But 3i Atlas remained luminously constant, holding its magnitude as though compensating for its growing separation from the sun. Some astronomers likened it to a candle flame that refuses to dim as the room darkens. Others compared it to a mirror adjusting its angle toward a dwindling source of light. But the truth is quieter and harder to define. It simply held itself calmly without explanation. When the oscillations ceased, radio observatories listened for the faint hiss that had once accompanied its path, a smear of broadband noise between 4 and 12 MHz, too subtle to encode meaning, too rhythmic to be chaos. That hiss, too faded, dissolving into the cosmic background the way a ripple dissolves into a lake, once the stone that caused it has sunk beyond sight. Some researchers believed this silence was meaningful. Others insisted it was nothing more than distant swallowing signal. Silence, after all, is both an ending and a continuation. In astronomy, it's often both at once. What lingered long after the radio quiet, however, was the corridor, the strange filamentary trail that 3i Atlas left in its wake. As it moved outward, instruments detected a faint sheath of ionized particles stretching behind it, like a thread bending light and solar wind with a delicacy that made scientists hesitant to name it. Not a comet tail, not debris, not plasma turbulence. It behaved more like an imprint, a memory of the object's passing etched briefly into space itself. Some called it a ghost corridor. Others, more poetic, suggested that space was still remembering the object, holding onto the shape of its presence before letting it dissolve. This wake puzzled even the most conservative analysts. A natural body can disturb plasma, yes, but not with such coherence, not with such persistence, not with such a gentle arching curve toward the galactic north. That curvature remained after the object was long gone from view, subtle but measurable, like the lingering bend of grass after an unseen animal has walked through it. Meanwhile, trajectory models displayed a final quiet surprise. 3-4. Atlas was no longer following the exact hyperbolic path predicted by gravity alone. Its outbound course tilted by a small but unmistakable angle, rising above the plane of the solar system. The shift was tiny fractions of a degree, but consistent, as though the object were drifting toward a region devoid of gravitational landmarks, toward a place without planets, without dust, without anything to draw it close. If this were a spacecraft, some whispered privately, one might call this a correction. If it were a natural fragment, one might call it coincidence. But astronomers are cautious with such words. They do not claim intention where none is proven, and yet the vector remained pointing into the quiet galactic dark like a gentle gesture made by something that had no need to explain itself. By this time, the community had grown calmer in its debates. The sharp lines that once divided natural and artificial hypotheses softened, and a quiet humility settled over the discussions. It became clear that certainty was no longer the goal. Understanding had taken on a different shape, less about categorizing the object, more about accepting that its behavior existed in a space between our definitions. The term anomalous interstellar reflector emerged as a compromise, a neutral phrase that contained both awe and caution, admitting that the object reflected more than just sunlight. It reflected possibility. As the object receded, researchers found themselves speaking less about classification and more about experience. They remembered the moment the brightness surged near the sun. They remembered the rhythmic pulses, the inverted dust tail, the magnetic signatures, the lull afterward. All these fragments, unresolvable alone, formed a mosaic of gentle strangeness, a portrait of something that did not demand understanding, only observation. Many nights later, atop a cold mountain in Chile, an astronomer stepped outside after logging the very last image of 3I Atlas. She looked at the quiet blank of the sky where it had once appeared, and whispered a sentiment shared by many who had followed its brief passage. Some mysteries aren't meant to be solved, only witnessed. Her words were not resignation, they were reverence, and that is the spirit in which Part 10 rests Traveller. Because the story of 3I Atlas does not end with revelation or discovery. It ends the way many true cosmic encounters end, with distance, with silence, with the object slipping gently into a region where our instruments cannot follow and our metaphors grow thin. Beyond Mars, beyond the sensitive edge of radio scans, beyond the light that once glinted from its surface there, 3I Atlas continues untouched by debate, untroubled by interpretation. Where it goes next, we cannot say. Whether it will drift forever in quiet darkness or brush another star's light one day, no one can know. But its passage through our sky left us something rare, the reminder that not all wonder needs closure. That understanding is not the only path to meaning. That the universe sometimes speaks in questions, not answers. And tonight, as the object fades beyond the telescope's reach, and the last echoes of its signal dissolve into the cosmic hum, let this be enough. You're not lost in space, you're part of it. It's all right to not understand. Sleep now, Traveller. The cosmos will keep watch. Traveller. Our journey drifts to a close now. We have followed 3I Atlas from the edge of the sun's fire to the quiet corridors beyond Mars, watching it shimmer shift and slip back into the darkness that shaped it. And as the last traces of its light fade from our instruments, we're left with something softer than answers, something quieter than certainty, a reminder that the universe is still moving, still whispering, still unfolding its ancient stories in ways we're only just learning to hear. Tonight, observer, you and I have looked into a piece of the unknown together. We stood at the threshold of a mystery that did not explain itself, and yet somehow it still offered meaning. That is the gift of the cosmos. Even when it keeps its secrets, it teaches us how to wonder. It teaches us how to be small without ever being lost. So let the silence of this moment settle over you like starlight on calm water. Let the unanswered questions rest. Let the strangeness of this interstellar traveller remind you that the universe has room for things beyond our imagining, and room for you too. Wherever 3i Atlas drifts now, its story continues. And so does ours. Rest well, traveller. Stay curious. The universe will keep watch. And if this story found you tonight, you're welcome to stay for the next.